Hello, good day. Welcome to Solvebeta today. So this is our summer coaching series, and we have been looking at certain topics for different classes: JS1, JS2, and this is JSS2. This is JS1 class. JS2, JS1. I don't basic 5 and JS1. 1, 2, 3. Hello there. Good day. 1, 2, 3, 4. Hey there. How are you? Welcome to Solvebeta summer coaching series. This is JS1, which is also known as Basic 7. JS1 Basic 7. So, summer coaching series is all about preparing students for the new term and also strengthening them on what they've learned in the previous term, what they've learned in the previous term. Now, the first topic we looked at was discounting, that's whole numbers. This is what we looked at, whole numbers. We looked at whole numbers. That's counting, learning how to write numbers in numerals, write numbers in words, and the likes. That's what we learned in the last class. And don't forget, we said that whole numbers are counting numbers. Example of whole numbers, we have 0, 1, 2, 3, 4, 5, down to infinity, down to the last number known. So that's what we said. Then we said that I don't know if it was this class, but I believe I said that 1, 2, 3, 4, 5, 6, although they are whole numbers, they are specially called natural numbers. Natural numbers. Natural numbers. Natural numbers. And we learn how to call words. For example, if you have this, we learn how to call this, write this in words. How do you write this in words? This is 3 million. So you can write the place by unit, tens, 100, 1,000, 10,000, 10,000, 100,000, and million. So this will be 3,506,000. So you 506,000, 506,000, 506,000. 105. 105. So this is how to write this number down. We looked at that here. Then we also saw how to write numbers in numerals. For example, you have this number. Yeah, we saw that this is units, tens, 100,000, 10,000, 100,000. This is million, 10 million, 100 million, then billion. I told you that billion can be likened to 1,000 million. A million in 1,000 places, or 1,000 in a million. Let me use money for example. 2 billion naira is the same thing as 1 million naira in 1,000 places. Or you can say 1,000 naira notes in 1 million places. That's very, very, very large. That's very, very, very big. So this is 2 billion. If you write this unit, tens, 100, 1,000, 10,000, 100,000, million, 100 million. Oh, sorry, 10 million next. 10 million, 100 million. Then you have 1,000. This should be 2. Did I call this 1,000? Sorry, billion. 100 million billion. This should be 2 billion. 2 billion. So it's 2 billion. Okay, in words, total in words. 2 billion. 2 billion. We have 2 billion. This is just a revision of what we learned. 2 billion. 809 million. 809 million. 109 million. 777,000, 777,000, 777,000, 77,000, 77,000. Then what's the last three numbers there? 777,800, 834, 800 and where do I write this now? Let me manage this please. 34. I hope you can see it. 34. 2,809,777,834. Again, 2,809,000,000. This comma means that you call this value, this place value, 2 billion. And I told you how to put a comma after 3 digits. 1, 2, 3. Put it from right to left. 1, 2, 3. Put 1, 2, 3. Also put 1, 2, 3. Put. So you have 2,819,777,834. So this is what we learned in the last class. Today we're going to move on to what is called LCM and HCF. LCM and HCF. Lowest common multiple, LCM and HCF. Now you must have done this in basic 5 or basic 4, basic 6 or basic 5, whatever syllabus or whatever your school is using. So we're going to be looking at LCM and HCF. Now, what does these two words mean? LCM is lowest, L stands for lowest, C stands for common, and M stands for multiple. HCF, highest or greatest. I like the word greatest because numbers are, a number is greater than the other, not necessarily higher by just grammar. This number is higher than this. This is greater than this. Again, different language. Highest common factor. So what is, now I'm going to use the one word. What is common to both words? The word common. Pun unintended. I did not mean that. What is common to both words? The word common to both words is actually common. This word common is common to both words. I'm going to explain that. When I say what is common to both words, what does this first word or phrase, I can use it as a phrase, lowest common multiple, this term, I think term is the best thing to call it. What does lowest common multiple have? Which word can I find lowest common multiple that I can also find the highest common factor? The word is actually common. So please keep that knowledge somewhere. When we say common, it's what you can find and you can also find. What is common to these two marker? Color black. With where I've put this cover here, color black is common to both of them. Can you see that? So let's go to let's go to lowest common multiple. Lowest common multiple. Let's go to lowest common multiple. Now, when we mean multiple, let's start with the word multiple. Lowest, we mean the least. Least common multiple. You can use least. I think I'll use the word least common multiple. That sounds better. Least, the least of the multiples. Now, when we mean multiple, look at these numbers. 2. The first multiple of 2 is what? 2. Why is it 2? 2 times 1 is what? 2. The first multiple of 2 is what? 2. The second multiple of 2 is what? 4. The third multiple is what? 6. Fourth multiple is what? 8. The next will be 10, 12, 14, down to infinity. Infinity. down to the last number that 2 can divide. Let me put it that way. Down to the last number you know that 2 can divide. So we have seen the multiple of 2. So it means that, take note of this, the multiples of 2 can divide. The multiples of 2 can what? Divide. 2 can divide the multiples of 2. Take note of that. 2 can divide the multiples of what? 2. Remember, I'm defining the term multiple. Now, let me go to 3. Let me write the multiples of 3. Let me differentiate this with 3. Let me write the multiples of 3. The multiples of 3, please forgive my handwriting if it's going this way. Multiples of 3 are, the first multiple is what? 3. The second multiple is what? 6. The third multiple, 9. The fourth multiple, 3 times 4, 12. Just be adding 3. The fifth multiple is what? 15. The sixth multiple is 18, and so on and so forth, to the last number that 3 can divide. So take note of this. These are the multiples of 2. These are the multiples of what? 3. Now, if we have to find common multiples based on what we have. Now, I think I should do this up to 20 so that the example would hit to commons. 16, 18, 18, 20, 20. Okay, let me stop 20. This one, 3 times 7, which is what? 21. So if I'm asked to write the common multiples, just common multiples alone, common multiples of 2 and 3. The common multiples will be those multiples you can find, and those multiples you can also find what here. So what are the multiples you can find here? We have first 6. So 6 is a common multiple. Let me see here for common multiple is what? 6. There are still other common multiples. Yeah. 18 is a common multiple. 18. And so on and so forth. There are still others. There are still other multiples. And so on and so forth. There are still other what? Multiples. So the least common multiple now will be the least of these two multiples, the smallest. Lowest common multiple is the smallest of the multiple. Lowest common multiple. The smallest of this multiple, which is what? 6. So the least common multiple of 2 and 3 is what? 6. Take note that you cannot find the common multiple if you are not dealing with 2 or more numbers. Meaning that for you to be able to find something that is common between some things, it must be 2. You must, by comparison, you cannot compare just one thing. Okay, take this example. Let's say you have, okay, let me use this, your mommy and your daddy. If you want to compare them, it has to be 2 or more persons you compare. Either you are comparing my mommy and my daddy. My mommy is this, my mommy is tall, my daddy is short. You are comparing 2 things. You cannot compare just one thing. You must relate it, or you must compare it to another thing. If you want to find what is common between your mommy and your daddy, or what your mommy does to you and your daddy also does to you, you are looking for what is common between both of them. You cannot find what is common to only one person. No. It must be from a point of comparison, meaning comparing it to something or another person. So, what do I mean? You cannot find the lowest common multiple of only one number. You must be told to find the lowest common multiple of 2 or more what number. The least common multiple of 2 or more what number. So, the least common multiple of 2 and 3 is actually 6. Why? All the multiples of 6 are here. All the multiples of 3 are what here. Now, common multiples will be 6, 18, and more. There are more. 6, 18. I think there's 20, 24, and more. There are more of them. But the least is what? 6. The reason why we are asked to even find the least is because to find the highest common multiple is actually very, very difficult, because we don't know the last. In fact, it's very, very difficult, because the last number, that the last multiple of this, and in fact this one does not have the last multiple because it's going to infinity. This one does not have highest. We cannot find the highest common multiple because it's going to infinity. This one we cannot find the highest multiple of 2 because we don't know the numbers. We have so many numbers. It's called infinity in maths. We cannot say this is the last number known, because there are so many numbers. There's an infinite, uncountable. Yeah, that's the word. we have uncountable numbers. We have uncountable numbers that 2 can divide. So we cannot say the highest one that 2 can divide is this. Did you get that? The same thing. That's why we cannot find the highest common, but we can only find the least common multiple. I hope I'm able to pass this knowledge to you well. So this common multiple of this and this is what? 6. Now there's a shorter way to find the least common multiple, which you know. But I want you to understand what common multiple is. I want you to understand it so that you can understand the principle of this. It will then help you when you are solving with that. Because that method is actually shorter. But if you understand this, you understand the principle. In mathematics, chase principle. Don't chase acts. It's only when you understand this principle that you should use what? Act, short form, short method. Know what it entails. So now let's take another example. Let me have 3 numbers and I should find the least common multiple of those 3 numbers. Okay, we have to find the least common multiples of 3 numbers. Don't forget you can rewind back and write this. So least common multiples of this number: 10, 12, 20. Least common multiple of this: 10, 12, or 20. So let's mirror the multiples of 10. The multiples of 10 they are, let me write it this way: 10, 20, 30, 40. Oh, yeah, that's correct. 40, 50, 60, 70, 80, 90, 100, 110. Then 12, 24, 36, 48. If you are going to be using this method, anytime you get a number that you have already gotten, okay, you write the multiples of 10 first. I'm getting the multiple of 10. So you're writing the multiples of 12. The moment I get a number that I have here already, I can stop. Meaning that 36, 48 plus 12 is 60. Now I have 60 here again. So I can stop here. Because I've gotten a common multiple between both 10 and 12. So now let's go to 20, 40, 50, 40, 60, rather. 20, 40, 60. I'm adding 20, 20, 40, 60. So you see that I've gotten 60 here. I've gotten 60 here. I've gotten 60 here. I have multiples of 10, I've gotten 60 here. I have multiples of 12, I've gotten 60 here. I have multiples of 20, I've gotten 60 here. So this is the common multiple. This is a common multiple. It's a common multiple. And if it's a common multiple, it's the least. Because the first is the least. There are still some other multiples. There are some other there are some other multiples there are some other common multiples of these 3 numbers. Let me look for another one for you. Here you have 72, 84, 84 plus 12. We're just adding 12. You might say this method is not fast. That's true, it's not fast, but it helps you understand. Plus 12, you have 108. Plus 12, you have 120. If you continue this, you have 10, 110, you have 120. So if you continue, and if you continue this, you have 120, 110 plus 120, 108 plus 10, 108 plus 12, 120. Then this one 60, 80, 100, 120. You see that is another multiple here. 120 is a multiple. So since 120 is a multiple, 60 is less than 120. Remember I said that you cannot find the highest common multiple because we don't know the highest multiple of this, and this, or there's an uncountable amount of multiples of this and so we cannot specify which one is the highest. So we cannot say this is the highest common multiple of the 3. So take note of that. So it means that the common multiples are 60 and 120. Then the least common multiple. Least common multiple is what? 60 because it's the smallest of this. So can you see how multiple works? Now let's go to highest common factor. Okay, I can bring out a property from this. I can bring out the property from this. I want to show you something. I'm coming. Let me look at it. Let me look at it. Now, if 60, in fact, if 60 is a common multiple of these three numbers, 60 is a common multiple of this number, it means that any product of 60 is also a common multiple of this. Any product of 60 is also a common. What do I mean? Any product of 60? I mean, okay. Let me not use the word any product of 60. Let me phrase it well. If 60 is a common multiple of 10, it means that if I multiply 60 by 2, I'll get 120. 120 is a multiple of this. 120 is a multiple of this. 120 is also a multiple of what? This. If I multiply 60 by 3, 180. 180 is a multiple of this. This can be divided by 180. 180 be divided by 12? Yeah. 180 can be divided by 12. Yeah, 160. Yeah, 15. Can 180 be divided by 20? Yes. Yes. So let me multiply 6 by 4 now. 240. This can 240 can be divided by 10. Or let me put it like this. If 60 is a multiple of 10, 60 times 2, 120 is a multiple of 10, 12, and 120, because 60 is a common multiple of the three of them. Let me take that. I want that to sink in because I'm building your brain mathematically. If 60 is a common multiple here of these three numbers, meaning that 60 can be divided by this one can be divided by this, 60 can also be divided by this. It means that any time I multiply 60 by another number, or when I multiply 60 by another number, by 2, by 3, by 4, by 5, the result is also a multiple of this. And I've shown you, I've used 1, 60, okay, and I've used 2, 60 times 2, 120. 120 is a multiple of 10, is there. 60 times 2, 120, 120 is a multiple of 12. 60 times 3, 60 times 2, 120, 120 is a multiple of what? 20. 3, let's go to 3. 60 times 3, 180. 180 is the multiple of this. I've shown you. 180 can be divided by this. 180 can be divided by this. Let me go to another number. 60 times 10, 600. 600 can be divided by 10. 600 can be divided by 12. 600 can be divided by what? 20. Please note that it will help you later in future. That's why you need to understand the principle behind this and not look for what? Acts. Now let's go to highest common factor. Highest common factor. So that's the property of lowest multiples of numbers that you need to know. Now let's go to HCF or GCF. Why is it called GCF in America? Greatest common factor. Greatest common factor. Let's go to highest common factor. Highest, biggest, greatest common factor. Highest common factor. Highest common factor. Now, what is a factor? A factor divides another word number. Just like multiple is gotten. Multiple is gotten when you multiply this number by another number. And take note that a multiple can be divided by this. The second multiple, go back to the second multiple of 3 is 6. So it means that 6 can be divided, this multiple can be divided by what? 3. Now, what is a factor? 3 can divide 6. 3 is a factor of what? 6. 2 can divide 6. 2 is a factor of what? 6. That's what a factor is. A factor of a number. A factor of a number. This is very important. Factors are, I dare say, more important or very more pronounced than multiple. What I mean more pronounced? You deal with them frequently in mathematics than multiples. Although both are related, the people don't know. That's why I've broken it down to you. I will try to show you the relationship. This is JS1, okay? I will do that for those in JS3. A factor of a number is another number. Let me know its algebraic term. It's another number that can divide the first without remainder. Divide the first without remainder. So the factor of this number, this is the first number, is another number, the second number, that can divide this first one without what? Remainder. Take note of that. You can memorize that. A factor of a number is another number is another number that can divide this one without what remainder. So we are dealing with two numbers, the first number and the second what number. So we say that this second number is a factor of the first number if it can divide the first number without what remainder. Just like if we have 4, we say 2 is a factor of 4 because 2 can divide 4 without what remainder. Now 4 can be divided by 3, but we will have a remainder 1/3. So 3 is not a factor of what 4. Now 4 is not a factor of 2 because 4 cannot divide 2 without remainder. In fact, 4 is less than 2 to give us a fraction half. So please take note of that definition. A factor of a number is another number that can divide the first number without what remainder. So from this, we then go to common factor. Common factor, just like common multiple. Common factor is a factor that is common to 2 or more numbers, or it's a factor that can divide 2 or more what number. It's another number that can divide 2 or more what number. Let's say we have 4 and 8. Then put them side by side again. Let me use mine. What are the factors of 4 and 8? Numbers that can divide 4. Take note that the first factor of 4 is number 1. 1 can divide 4. Which other number can divide 4? 2. I want you to think 2. And which other number? 4. So 1 and the number itself can always divide the number. 1 and the number itself can always divide the what number. Please take note of that. 1 and the number itself can always divide the what number. Now let's go to 8. What is the first factor of 8? 1. Which other number can divide 8? 2, 4, and the number itself 8. 1, 2, 4, 8. And I want you to know this. I want to show you something. If 8 is a property of factors, if 8 can be divided by 2, the result is also a factor of what? 8. Meaning that if 8 can be divided by 2 to get 4, it means that 8 can also be divided by 4. It will give you this 2. 8 can be divided by 2, you get 4. It means that 8 can also be divided by this same 4 that you get, the result that you get, and you get this word 2. Please take note. You can use that to find factors of a number. So now, what are the common factors? The common factors are the ones that can divide these two, the ones that can divide this number can also divide this other number. You can divide both of them. So you have 2 and 4. 2 and 4 can divide 4 and can divide what? 8. So the HCF, the highest of them, greatest of them is what? 4. The greatest of them is what? 4. The greatest of them is what? 4. The greatest of them is what? 4. Are you seeing it? 4. So are you seeing it? So that's how to find the HCF. Simply. There's another way to find the HCF, which we would later do, maybe in JS2. That's when you have understood prime factorization very well. You have done prime numbers. So now let's move on. Let's take a bigger number and see how we can find the HCF. I believe I can erase this. If you've not written it, you can rewind. I believe you know how to rewind. Rewind, pause, and watch. Now, okay, let's look at it. Let's take this example 2. Find the HCF of 3 numbers. The HCF of 12, 20, and 36. 12, 20, and 36. So we have to write the factors of 12. Factors of 12. What are the factors of 12? Factors of 12. Factors 12. You have 1. Remember I told you that 1 can divide every number. 2 can divide 12 to give you 6. If 2 can divide 12 to give you 6, it means that 6 is a factor. So keep that somewhere. What else can divide? Because we have to arrange it, what is it called? In ascending order. Can 3 divide 12? Yeah, 3 can divide 12. 3 can divide 12. 12 divided by 3 is 12 divided by 3 is 4. So 4 is a factor. So 3 after 3 is 4. We can now put this 4. We can put 6. Can 7 divide 12? No. Can 8 divide 12? No. Can 9 divide 12? No. 10, no, then 12 itself. 12 is the other number that can divide this, and 12. So now let's go to 20. What are the factors of 20? 1. 1 and 20. 1 times 20 give you 22. 2 times what will give you 10. So 10 is a factor. 20 is also a factor. Can 3 divide 20? No. 4. 4 times what will give you 25. 5 is a factor. So after 4 is 5, definitely. Then 6, no. 7, no. 8, no. 10, and what? 20. Then let's go to 36. What are the factors of 36? 1 is a factor. Can 2 divide 36? Yes. 18. 2 times 18 will give you 36. Let me keep 18 here. Can 3 divide this? Yes. Yeah. I'm going to do that. I think I will do that if I have the time. I will try to see if I can incorporate it. How do you know when 2 can divide a number? How do you know when 3 can divide a number? How do you know when 5 can divide a number? I think I will do that. I'll do that in the next class. It's called rule of divisibility, to help you to know when 2 can divide the number, when 3 can divide the number, when 5 can divide the number, and I think I will stop with 7, when 7 can divide the number. So I will do that. So 3 can divide 36 to give you 12. You have it there. Can 4 divide 36? Yeah. 4 times 9, 36, 4. So you have 9. Can 5 divide 36? No. Can 6 divide 36? Yeah, 6 can divide 36. 6 times 6, 36. So after 6, 7 is not there, 8 is not there. So you have 9, this 12, this 18, and what? 36. So having done that, what is the common factor or common factors if there are 2? Common factor. That means factors that can divide all of them. What are the common factors? I can see 1 here. I can see 2 here. You can do something like this to show that 1 is there. You can see 2 is a factor also. It's a common factor. Is 3 a common factor? No. Why? 3 is here, but 3 is not here. So it's not common to 3 of them. It's common to both these 2, but it's not common to 3 of them because we are looking at what is common. Let me get back to the example. If you are looking for what is common between you and your siblings, let's say you have 3 siblings. Let's say you are a girl, you have a boy, a brother, and a girl. So if you want to ask what is common between 3 of you, you are siblings, meaning you are brothers and sisters. But if you now want to narrow it down, what is common between the 2 of us here? We are both what? Girls. We are siblings and we are what? Girls. It's common to you, but it's not common to the 3 of you. It's common to you and your sister, but it's not common to your brother because your brother is not a girl. The same way, 3 is common to 12 and 36, but it's not common to 12, 20, and 36. So we cannot say it's a common factor of the 3 of them. So we'll go to 4. 4 is here. 1, 2, 3 is here. 6. Okay, 6 is not there. 6 is not there. 12 is not there. So these are the common factors. The HCF then, by reason of this, is 4. So the HCF of 12, 20, and 36 is what? 4. Now what does this imply? This implies that 4 is the biggest number that can divide these 3 without what? A remainder. There's no any number bigger than 4 that can divide these 3 without a remainder. None. That's the implication of the greatest common factor, the highest common factor. No every number that can divide these 3. No number bigger than 4 can divide these 3. Nowhere. You can try it. That's what mathematics does for you. No number bigger than 4 that can divide it. So with this, I will give you something to do. So let me give you something to do. I hope you are enjoying this. If you're enjoying it, please like, comment, and share this video. Oh, okay, so let me give you something to do. Find the HCF and LCM. Could it be possible, before I get to that, could it be possible that you have 3 numbers and there are no HCF? Yes. There's no LCM. Yes. Look at this. 10 and 17. If you want to find the HCF. What are the factors of 10. 1, 2, 5, 10. What are the factors of 17? 17. 17 can only be divided by 1 and itself. 1 and 17. So the highest common factor here is 1. Is 1. Is what? 1. Only 1. So there are some times that there's no higher common factor apart from 1. Apart from what? 1. There are some times, yes, there's no highest common factor apart from 1. But when it comes to LCM, there will always be a least common multiple. There will always be. Aside 1. At times, you might be asked to find the highest common factor of 2 numbers. You will not get any other number apart from 1. That means there's no number that can divide both of them apart from 1. But when it comes to LCM, you must get an LCM. 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 And if you look at it very well, at times the LCM is always the product of the two numbers. It's always the multiplication of the two numbers. At least there must be the lowest multiple of this, which is 10 and what? 70, 170. The lowest common multiple is 170. And this, let me stop that. Let me stop there. I hope you make the most. Why do I feel like I'm teaching JS3? I think I will keep this video and JS3 will also watch it. Yes, they will also watch it because I've broken this down. I've given the simplest and the advanced understanding of this. So I will share this for JS3 to watch also. So now find the LCM. Find the LCM of this one. 15. Okay. Let me find the LCM and HCF or both. So what does it mean? You find the LCM of number 1 and find the HCF of number 1 too. You find the LCM of number 2 and also find the HCF of number 2. You find the HCM and also find the what? LCM. You find the HCM and you find the what? LCM. I hope you can do that. I hope you can do this number 2. It will be challenging, but try. It will be, when I mean challenge, it will require much effort, but try. I believe in you to do it. So these two are enough. They are enough. But should I add one for the road? Let me add one for the road. 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 LCM and HCF of this. Oh, this number is big. This number is big. JS1 number is big. Then put 14 and 30. 14 and 30. 14 and 30. 14 and 30. 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 35. 35. I want to task you. I don't want it to be too simple. I don't want it to be too difficult. So do these 3. Please don't forget you will find the LCM of all of them. LCM. Then also find the HCF of the 3 questions. So see you in the next one. Bye.